And here's the answer to the quiz question. So if the game is played once, what is the outcome? If you use the check method, you will realize that both players have a dominant strategy, which is to offer a warranty. So the Nash equilibrium of the one-shot game is the pair of strategies is for both firms to offer a warranty. Suppose we repeat the games 3 times. Will the outcome be different from your answer to A? And we use backward induction here, starting in the final period, period 3. Then we face the one-shot game, and each firm still has a dominant strategy then. So the Nash equilibrium in the final period is to offer a warranty, and then you go back to period 2 and then period 1. And given that both firms offer a warranty in period 3, it's also optimal to offer a warranty in period 2 and in period 1. So no change in the player's behavior. And then if we repeat the game indefinitely, so what is then the outcome? Now that is somewhat more complicated. We assume that both Honda and the other firm, they use a Grimm trigger strategy. So we determine the expected payoffs from cheating incorporating to Honda. If it cheats, then it will offer a warranty today, giving it a payoff of 120, given that Suzuki will not offer the warranty today. But then Suzuki will retaliate, and it will also offer warranty in all future periods, which limits Honda's future payoffs to 20. So the payoff of cheating is given by this expression over here, and if Honda cooperates and sticks to the agreement not to offer a warranty, then it will get a payoff of 50 in every period. It is attractive for Honda to stick to the agreement when one is larger than the other, so Honda is indifferent between the two if they are equal. So we set the two expressions equal to each other. We simplify and solve for D. And again, using the mathematical expression for these infinite sums, that you can write them as D over 1 minus D, we arrive at the answer that Honda is indifferent between cooperating and cheating when D is exactly equal to 0.7. And that completes our answer. Honda is indifferent between the two options when the discount rate is 0.7. Question to you, what happens if the discount rate is 0.5? Well, you can do the calculations, but of course, if you know that Honda is indifferent when the discount rate is 0.7, a discount rate of 0.5 means that the future is less important to Honda. So cheating today and getting the 120 instead of 50 becomes relatively more attractive. So in that case, Honda will strictly prefer to cheat. And the equilibrium of not offering a warranty is not sustainable. And then we move to sequential games. So in many games, players make decisions one at a time, and when deciding, they take into account what they have observed their opponent doing. So, and we cannot no longer rely on a matrix representation, but we will use a tree. So we will model the game in extensive form. So an extensive form game or decision tree is a representation of a sequential game that shows both the choices that players have and the timing and the sequence in which these different choices unfold. And we will use backward induction to solve these games. So we first look at the last step, so the final move that will be made by any of the players, and then we will move backwards. So we return to the decisions that Warner Brothers and Disney face regarding the release of their films, Lego Movie 2 and Frozen 2. And we suppose that there are 3 possible choices, 3 possible release months: March, May, and December. So in matrix form, in normal form, it looks as follows. Suppose that Disney has to decide what to do, not knowing what Warner Brothers decides, and vice versa. Then we use the check method in order to find a Nash equilibrium, and we arrive at two possible equilibria. So Warner Brothers May, Disney December is one Nash equilibrium, and we have a second Nash equilibrium being Warner Brothers choosing December and Disney choosing May as its opening date. But this is conditional on the game being a simultaneous move game. Both firms need to decide what to do without knowing the decision by the other firm. But now we assume that Warner Brothers moves first, so it first needs to decide on a release month. It has to commit to that, and then Disney can respond to it. It can observe what Warner Brothers has chosen and then decide what is optimal for Disney to do. So we use backward induction. So for each strategy that Warner Brothers may choose, May, March, December, we evaluate the best response by Disney. And the outcomes, they are referred to as subgame equilibria. So we cut the overall game into smaller subgames and we solve for the equilibrium decision in each of these subgames. And then if we know the optimal response by Disney given any of the choices made by Warner Brothers, we can go back to the decision by Warner Brothers, what is optimally for Warner Brothers to do, given that it knows how Disney will respond. So let's model this as a tree. So the first mover is Warner Brothers. It needs to decide at node A whether to release in May, December, or March. Disney observed this, and at node D, for example, it knows that Warner Brothers has decided to release in March, so it can decide whether to release in May, December, or March. And if we look at this subgame, suppose that Warner Brothers has decided to go for March, we know and we see immediately that it's optimal for Disney to go for May, because that will give it a payoff of 300, which is more than the 200 or minus 50 that it would earn if it would release in December or May. Given that Disney observed that Warner Brothers releases in December, Disney knows that it's optimal to respond by releasing in May, because it will give it a payoff of 300 instead of 0 or 100. So we denote these optimal decisions by Disney by using a check. And Warner Brothers, in deciding when to open or when to release, knows how Disney will respond, because it assumes that Disney is a rational, profit-maximizing player as well. So Warner Brothers knows that if it will release in December, Disney will respond by opening in May, giving Warner Brothers a final payoff of 200. It also knows that when it opens in May, Disney will respond to that by opening or opening in March. It will respond by opening in May, which will give Warner Brothers a payoff of 100. So when it's choosing between December and March, it's optimal for Warner Brothers to choose December, because that will give it a payoff of 200 instead of 100. And then when Warner Brothers releases in May, Disney will optimally respond by opening in December, and Warner Brothers then knows that if it opens in May, it will receive a final payoff of 300, which again is more than 200 and the 100. So Warner Brothers knows that it's optimal to open in May, because then Disney responds by opening in December, and the final payoff to Warner Brothers is 300. So the subgame, perfect Nash equilibrium, in this particular case is Warner Brothers opens in May or releases in May, and Disney releases in December. Notably, we observed that in the one-shot game, the simultaneous move game, where both players did not know and could not respond to what the other player did, there were two possible equilibria, two Nash equilibria. And we observed that if this is a sequential game where Disney can respond to what it observes Warner Brothers doing, we have one unique subgame perfect Nash equilibrium. And that already brings us to the following quiz. So again, we have two firms, Games Grew and another game producer, Playthings Incorporated, PTI, and they are considering television advertising campaigns for the upcoming holiday season. Advertising is expensive. Each firm will earn a greater profit if they both decide not to advertise. In that case, they will earn 50 million each. If both choose to advertise, each firm will earn 30 million. If one firm advertises and the other one does not, the advertising firm earns 70 million and the other 20 million. So you can put this into a matrix and you need to answer the following questions. Create this matrix, this payoff matrix showing the normal form of the game. List all the Nash equilibria of the one-shot game. If the game is played sequentially, and Grew is the firm that has to decide first on whether to advertise or not, what will the outcome be? And does Grew have a first mover advantage in this case? So by moving first, is it able to reach higher profits? These are the 4 questions, and I wish you good luck with answering them.